Okay, we're going to take a look at an example of conservation of energy. And just like the name says, energy is conserved. What that means is that if you start out with a certain amount of energy, that total never changes. All that's going to be happening to us is it's going to be changing form. Now you need to realize that there are two types of energy that we're going to be focusing on. The first is gravitational potential energy, and that has the equation mgh because it has to do with height. We derived that before. And the second one is kinetic energy. And kinetic energy is the energy of motion. As soon as you're moving, you've got kinetic energy. So those two equations are going to be real important to us. All right, we have an example here, and we're on top of a building that's 20 meters high, and I've got a water balloon. And I'm holding that water balloon, and I'm going to drop it. And when I drop it, hopefully you realize as it falls down, it's losing height or potential energy, but it's simultaneously speeding up, which means it's gaining kinetic energy. So what we're going to do is, let's take a look at a couple problems at 3 different points. Let's take a look at if we were at the top. At the top of the building, I want to know how much potential energy do we have and how much kinetic energy we have. Now, as far as kinetic energy, I'm assuming, unless you're told otherwise, that I'm just dropping it from rest. Well, if that's the case, if it's starting from rest, the velocity then would equal 0. And if the velocity is 0, my kinetic energy would be 0. The potential energy, on the other hand, will have a value because we're up high. So we're using our potential energy equation, mgh, and we know the mass. The mass is 10 kilograms. The acceleration due to gravity, g, is 9.8. That is never going to change. And then the height, if you look at it, we're at a height of 20 meters. So now I'm going to multiply those 3 values together, and I'm going to get 1,960 joules. Now, what we need to look at is we need to look at the total energy. And the total energy is going to be the sum of the kinetic energy and the potential energy. And that's going to be the case no matter where we are. So our total energy is the sum of the kinetic energy and potential energy. Well, my kinetic energy is 0. My potential energy is 1,960 joules. That means my total energy is going to be 1,960 joules. That number is never going to change. My kinetic and potential can change, but the total energy won't. So let's take a look at now, what if we're at the halfway as it's falling down? We're halfway down. Well, in this case, I'm going to have both kinetic and potential. I can't find the kinetic right away, but we can figure out the potential energy because we should know the height. And if I'm halfway down, the height is going to be 10, because half of 20 is 10. I multiply those together, and I'm going to get 980 joules. All right, so I've got my potential energy. I know the total energy. And so now, using the relationship that the total energy is going to equal the potential energy and the kinetic energy, hopefully you see we can put this puzzle together. This 1,960 joules is never going to change. I can solve for kinetic energy, and my potential energy is 980 joules. To solve for kinetic energy, I'm going to subtract 980 from both sides, and when I do, I'm going to get kinetic energy equals 980 joules. All right, we want to finish this off, and we're going to finish as it hits the ground, just before it hits the ground. So your answer for velocity will never be 0. So I want to say at the bottom, as it hits the ground. Now, as it hits the ground, I should be able to figure out the potential energy because my height would be 0. So if my height is 0, well, 0 times anything is 0. So now we've got the problem with the kinetic energy, but since this relationship with total energy never changes, I know that the potential energy is 0. My total energy was 1,960. That means that's going to be my kinetic energy. Now, if we took it a step further, and if I asked you to find the velocity, well, if you have the kinetic energy is going to equal 1/2 mv squared. My kinetic energy, we said, was 1,960 equals 1/2 times 10 times velocity squared. First thing you're going to do is take the 1/2 times 10, which is going to give you 5, and I'm going to need to divide that 5 by both sides. But the last thing is to find v, we're going to have to take the square root. And when we do that, you would get a value of 19.2, I'm sorry, I'm running out of room, meters per second. And that's the approach you're going to take with all of the conservation of energy problems. Good luck.